talk about experiment 2E1, work done by a motor. Upon completion of this experiment, you should be able to measure the electrical energy input of a motor, measure the mechanical work out of a motor, and measure the efficiency of an electric motor lifting system. Our equipment that we'll be using includes a DC motor, that's this little part here, and the center of the screen, the stopwatch, power supply, the nylon cord again, our ruler, going to be using S-hooks, and our single pulley right here. We're going to be using the slotted weight set, the spool pulley that's on the front of the motor, and our support stand set, hooks, crossbars, and the universal lead set. An electric motor is an electromechanical device. It converts electric energy into mechanical kinetic energy or motion. Assume that you're using an electric motor to lift a load. The electrical energy used by the motor is converted to mechanical energy or work. When workload is lifted, the electrical energy input is the product of the motor voltage, the motor current, and the time required to lift the load. This is expressed in the equation V times I times T. This electric energy is the electrical energy work input to the system. This can be expressed with the following mathematical expression. Work in is equal to energy, which is equal to V times I times T. And the V stands for volt, the I stands for current, the T stands for time. The mechanical work by the motor is the product of the lifting force and the distance that the load is lifted. This is expressed in the equation work equals force times distance. That's our mechanical work. And basically we're measuring the height that we're lifting multiplied times the weight of the load. You will use an electric motor to lift a load in this experiment. You will measure the electrical energy input to the motor and the mechanical work output of that motor, and then calculate the efficiency of the motor lifting system. It's now time for the procedure. In the lab setup part, this is on page 2-42, you're going to look at figure 1, and basically figure 1 is this angle right here. You mount the two support rods to the breadboard in the position shown in this diagram. Notice they're over to the right and in the corner of the breadboard. There's some measurements in the diagram on page 2-42. There's an overhang of this device that has to be about 3 inches. You've got your pulley and your electric motor hanging off the edge as well. Notice that the breadboard is on the back of our cart. Step 2 in the setup. Using the rod connectors, mount the crossbar to the support rods. Position the crossbar at the top of the cross rods, at least 2 inches of the bar extending over the edge of the breadboard, like you see at the top of the diagram here. Step 3, you want to attach the hook to the rod connector. That's this thing right here. That's the hook. You're going to slide the rod connector onto the crossbar across the top up here, snug it up. Hang the single pulley from a little small hook here, and you thread the line in the next steps. Make sure your DC motor and the breadboard is in position that you see in figure 2. It's like hanging over the edge here. And then you connect the AC-DC bolt and make sure that you're connecting it to this side over here, and you're going to use the 0 to 24 jack, and that looks like this one.